finished talking about Rolle's theorem and the mean value theorem. Mean value theorem is a more general case. Rolle's theorem is a situation in the mean value theorem where the instantaneous velocity is 0. So just to recall, for those who don't remember what the mean value theorem was, the mean value theorem stated that on an interval from a to b, a closed interval from a to b, of course, have a continuous and differentiable function, that there is some letter c such that the derivative is equal to the slope of the secant line. Okay, remember, the slope of a secant line is just a line connecting 2 points on an arch. So on an arc, an arch, curve, whatever you want to call that. So if you find the slope of a line, that's the slope of the secant line. Take the derivative of the function that those points were on that created the secant line, and you get the derivative. In other words, the slope of the tangent line. So for example here, if I have 2 points A and B, and those 2 points are on some curve, A and B, this would then be f of A, and this guy would be f of B. The slope of the line connecting those 2 points, right, that slope would be the change in y over the change in x, f of b minus f of a, all over b minus a. That's a secant line. Well, f prime of c says there is some c value in here such that there's a tangent line that has the exact same slope. Okay, so that's what this is saying here. And if we put it in terms of some physics, maybe you could say that the average velocity has to equal the instantaneous velocity at some point over that interval. So the example we're going to use here, the mean value theorem, is a speed trap. We're going to have cop number 1 here, and 5 miles down the road, we're going to have cop number 2. And they're going to be getting an unsuspecting customer here. This guy is going to be cruising along in his nice little car. Okay, he's got, this is a fast car. I mean, geez, look at that thing. Got the antenna going up here. He's got the radio blaring, headlights on. Good man. All right, he's going to be cruising along here. And at 3:30 in the afternoon, cop number 1 observes him going 55 miles per hour. And at 3:34 p.m., cop number 2 observes him going at 50 miles per hour. All right, so it's only natural you're driving down the road and you see a cop, you put the brakes on. Okay, they take a radar test on you, and boom, okay, he's not speeding, he's good to go. Well, this is a speed trap here. You get 2 different cops, and then down the road here you got some cops sitting there, and they say, hey, breaker 19, we got a white little sedan here. He's speeding. Pull him over. License plate HKD 5553. And then they pull him over. It's called a speed trap there, friends. This actually is illegal in the United States for them to do this kind of a speed trap here, similar to when you enter the turnpike and exit the turnpike. They record the times, and they can theoretically say, hey, you know what, you're going an average of 70 miles an hour, speed limit 60. You had to be speeding. That's something that's illegal in the United States currently, except it's been, a trial run's been done in New York City. However, this is very prevalent over in Europe, that they use these speed traps. In fact, they have microchips in a lot of the registration cards over in European countries now where they do this. So at any rate, here's the mean value theorem in action. Mean value theorem says that the derivative at some point, in other words, your instantaneous velocity has to be equal to your average velocity at some point. So, since this guy was going 55 miles an hour and 50 miles an hour over a span of 4 minutes, okay, his distance changed by 5. Okay, so his change in y value is 5, right? He went 5 miles. When you want to call this mile marker 30 and mile marker 35, and you can say 35 minus 30 is 5. And his x value, his time, 3:34 minus 3:30, changed by 4 minutes. So we have 5 miles, which I'm going to change now the minutes into 1/15 of an hour. And dividing by a fraction, same as multiplying by the reciprocal. We have this guy going an average speed Okay, that's his average speed is 75 miles an hour. But the mean value theorem guarantees us that he was going at least 75 miles an hour at some point in order to achieve that average. Okay, and since the speed limit was only 60 miles per hour, boom, we can write this guy a ticket. He is speeding, and he is in trouble. All right, so mean value theorem guarantees the instantaneous velocity there, right? The derivative, the slope of the derivative is going to be equal to the slope of the secant line, or in this case, the average velocity. There's the mean value theorem at work. Plenty other examples, that we can do, and we'll look at several of these problems in class. Have a nice one.